So now you have a liming recommendation. Like on the previous slide or the previous video, we came up with 5,000 pounds of lime per acre. So do you really apply 5,000 pounds of lime per acre? Yes and no. Depends on the lime. All right. So how do you know how much lime to apply? You know how much lime to apply because of the fact that all liming materials are not equally effective. And you'll come up with the amount of lime to apply based on knowing the type of lime that you're going to apply and its effectiveness. So lime is not lime is not lime. How much do you know to apply? So you need to know the liming source. And there are some common liming materials that are present on the market today. You have limestone. You could have calcite, it's limestone. People call it limestone. It's calcium carbonate, right? And you might have limestone that's dolomitic. We have dolomitic formations here in northwest part of Ohio. And this liming material contains not only calcium, but calcium and magnesium. You might have something called marl, which is calcium carbonate, but it contains clay. So this has some impurities in it. You might use hydrated lime, which is calcium hydroxide. You might use something called burnt lime, which might be also known as quicklime. It's calcium oxide. You might use blast furnace slag, calcium silicate. And lime can be pelletized, it could be powder, it could be in liquid form. If you're interested in biochars oftentimes are high in pH, they're basic, and they sometimes act like good liming agents. In fact, there's been a study in the state of Washington that showed that the biochars that they used to apply to some wheat farms where the soil pH was relatively low, raised the pH and improved crop yields. So what you need to know is that not every liming material is the same. And look at the chemical formulas that you see on this slide. Are they all the same? They're not all the same. What we typically do when we determine the amount of lime to add is the amount of lime to add is always equivalent to calcium carbonate. And I'll come back to this concept again in some subsequent slides. But all these liming agents that you see on this slide are based on the equivalent to calcium carbonate. And there's a reason for this. If you were to go to the periodic table and look at the formula weight of calcium and carbon and oxygen, and there's three of those here, this number for the molecular weight of calcium carbonate adds up to 100. And 100 on a percentage basis is a really nice number to work with, right? As a baseline. And so all these other liming agents are compared to the effectiveness of calcium carbonate. And we'll talk about this in a little more detail in the next section.